welcome everyone. Super excited to have you all here at Radar HQ. We moved into this space a little bit less than a year ago, and this is our first external event that we're hosting in the space. As a location company doing IRL events, it's like very important to us and on brand for us, so we're excited about that. I think this is also my first iOSoho event that I've attended in like 7 years. I was telling some folks earlier, I went to one back in 2016. Literally a few months after we incorporated the company, and there was a talk by an iOS engineer at Stripe, and he was talking about Stripe iOS SDK. Took a bunch of notes, and that was very inspiring to me. So hopefully this talk is interesting and useful to some of you all as well. So the talk is called Pushing the Limits of Core Location. Before I dive in, I'll just give a little bit of context on why I think I'm sort of qualified to talk about this topic. So just a bit about Radar. Radar is full stack location infrastructure. We build developer tools for location. So geofencing and location tracking SDKs, geocoding APIs, dashboards. We started the company back in 2016, founding team at Foursquare. So we've been in location space in the New York City tech scene for over a decade now. And we're a little over 50 employees, most based in New York City. I'm the CEO, technical co-founder here, built the first version of our iOS and Android SDKs. Still commit code to our SDKs, which I'm sort of like the old man who's still driving. They probably should take the keys away from him. That's me with our SDKs. Been hacking on iOS apps since back in 2009. Back when I was an undergrad, the App Store came out. I had a buddy who built a game that hit #1 in the App Store, and he made $1 million, which I thought was really incredible and seemed like an unfathomable amount of money to me as an undergrad. So I thought I would do the same. So I used to play a lot of Fall Down on my TI-83 calculator in high school. So I built sort of an iOS version of it called Space Rush. I did not make $1 million. I think I made like $200, but good learning experience nonetheless. Graduated from undergrad, started my career at Microsoft, but quickly realized that I really wanted to work at Foursquare. I was just obsessed with this Foursquare app, checking in, earning badges. So I sort of made it my mission to get a job there. I built an iOS app for Foursquare super users called Hopscotch. I got noticed by one of the co-founders, turned that into an internship. And so interned at Foursquare, worked there full time for a little bit on the product team. Met my co-founders there, Kobe and Tim, so I circled them in pink. So that was sort of where I first fell in love with location and got exposed to consumer location use cases. I then left to run product at a startup here in New York called Handy, which is sort of like an Uber for home services. Wanted to build a Uber-style location tracking system for service providers on our platform, which is kind of where I first got exposed to the more logistics side of location use cases. And it was really challenging to build. I think we looked at core location and said, hey, we'll put an iOS engineer on this, we'll put an Android engineer on this, web engineer to do Google Maps integration. We'll have this whole thing built in a month or two. And it turned out to be really, really challenging. So kind of took that experience. That was part of the inspiration for Radar. And I've really spent the last like 6 or 7 years just kind of walking around, testing core location, kind of staring at, all of its different behaviors and quirks. And, we as a company have been seeing how far we can push it from an accuracy and a battery efficiency perspective. So that's kind of the subject of this talk. I thought I would try to, take an inventory of biggest learnings, biggest pitfalls, things to watch out for, some cool kind of superpowers and, kind of lesser known or undocumented features that I think are really cool. And also just based on our experience over the last 6 or 7 years, what we think the next 6 or 7 years of core location might hold. The title of this talk is Pushing the Limits. I was like, I need a theme for this talk. What comes to mind when I think about pushing the limits? Do we have any folks who are fans of like video game speedrunning in here? Speedrunning on 1 or 2. Okay. One of my favorite video games is Super Mario World. I watch a lot of Super Mario World speedruns. So I thought I would just pepper this talk with Super Mario World gifts. So hope you enjoy that. So in terms of the lay of the land, what are we going to cover today? The 5 topics. First is just the basics of core location. Raise your hand if you've worked with core location before, sort of assuming that most of you have. So we can breeze through this, but just as a refresher. We'll talk a little bit about what we've learned about what's going on under the hood. When you request a location update with a certain accuracy, what is the phone doing, and what should you keep in mind there? What are some of the challenges building with core location that if you or implementing location-based features in your iOS app, like just things to keep in mind or things to watch out for. Magic tricks and cool features that I think are sort of lesser known, but really powerful. And then also some thoughts on where this might be going in the future. So, let's start with the basics. Obviously, location service in iOS all rolls up under the core location framework. Sounds like most of you have worked with it before, but relatively straightforward. You get a CL location manager instance, you set your delegate, you request permissions, you configure some settings, for example, your desired accuracy, and then you request a location update or you start updating location. So relatively straightforward. If you're doing things in the background, there are some pretty cool services and capabilities, significant location change, region monitoring service, aka client-side geofencing. It's the ability to set up circular geofences or also monitor iBeacons. And then the visit monitoring service, which we'll talk a little bit about. Radar SDK uses all of these under the hood. We try to abstract away some details of these. If you've ever messed around with location services on Android, there are a lot of things that are similar, but also some differences. There's no significant location change service or visit monitoring service. There's this Fuse location provider, which you can request locations in specific intervals. You can request to get locations passively from other apps. Kind of cool. There's also client-side geofencing capabilities with dwell events, which is kind of cool as well. So, those are the basics of location services. What happens under the hood when you request a location update from iOS? I think a lot of folks would say, the iPhone is going to power up the GPS receiver and get a location from GPS. And that definitely happens. GPS is one of the ways your phone can determine where it is. GPS is actually really cool. I'd encourage folks to, go on a Wikipedia binge related to GPS, but military technology opened up for civilian use. They were kind of fuzzing the accuracy for a while. And I think it was President Clinton who was like, super accurate GPS for everyone. And so, your iPhone has a GPS receiver that can, range 3 satellites. Basically, all these satellites are broadcasting timestamps. And based on the drift in timestamps from satellites, it can calculate the device's location. You can get more than 3 satellites. You'll also get altitude and kind of increase the accuracy. But there are lots of other things that the phone does and can do to determine its location. Obviously, Bluetooth ranging, if the phone can detect if it's within range of a Bluetooth beacon, that's one way to do it. GPS doesn't really work super well indoors or in back alleys in New York where it's kind of tough to get a clear view of the sky. So both iOS and Android devices have built-in Wi-Fi scanning. So devices can triangulate their location based on nearby Wi-Fi signals with known lat longs. Same thing with cell towers. If you ever watch CSI and seen the sort of cell tower pings on a map, there's that. And then you can also determine a very coarse location for a device using IP address, if that IP address has a known location, or if an IP address range has a known location or country or whatever. You can sort of plot these on a spectrum from, I've kind of ranked IP geolocation as lowest accuracy, but also kind of smallest pain in terms of no specialized hardware permissions, lowest battery drain, all the way to Bluetooth ranging is kind of accurate down to a few inches, highest accuracy, but sometimes specialized permissions or hardware requirements. If you're using core location, you're not really saying, hey, I want a Wi-Fi scan location or I want a GPS location. You're expressing a desired accuracy. And under the hood, the phone is saying, okay, cool, the developer wants a location that's accurate down to 100 meters or better. Let's sort of choose based on the availability of services on the phone, based on whether we have a clear GPS signal or not, if Wi-Fi is on or not, the most appropriate hardware to use to grab a location fix. Our SDK tends to use the accuracy 100 meters quite a bit. We find that's kind of the best balance of accuracy and responsiveness, battery efficiency. But when you set a desired accuracy, that's sort of what's happening. So seems pretty straightforward. What are some things to keep in mind if you're working with core location? These are things that we've run into over the years that some of our customers that built their own solutions in-house have run into. This is not a Super Mario World GIF. This is Super Mario Brothers 3, but our CTO, Tim, says that sometimes folks just have to wander the desert with location services to sort of like get a feel for some of the challenges. So I wanted to, toss that in here. and just call it a couple things. I think the first is changing location permissions. When we started the company, there was actually no separate background permission on Android. It was possible on iOS to request always or background permissions and not give the user the option to grant foreground permissions. Uber sort of famously got in trouble for doing this. Over the last 5 or 6 years, Apple and Google have really raised the bar on requesting location permissions. You can now grant location permissions temporarily. You have to grant foreground permissions before you can grant background permissions. And most recently, both Apple and Google have introduced approximate location permissions. So a lot is changing here. Obviously, starting to stay on top of this. Ultimately, we think this is good for consumers. I don't think there are very many folks who are accidentally opting into location these days, but just sort of one thing to keep in mind. I think the second thing is, if you fire up a CL location manager and you start requesting locations and you go for a walk, you're going to get slightly different location pings every single time. And I think we're all used to, writing code that behaves a certain way. We'll write some unit tests and pull everything passes. We're good. It's really challenging to do that with location services because one, the simulator does not behave the same way as a real iOS device does, and two, just a function of where you are on the street and what GPS satellites are overhead at any given time or network connectivity or whatever. There's always going to be slight variations in the location pings you're getting. Also, limits to accuracy. I fired up Apple Maps this morning. I took a screenshot. I was actually here in my apartment, but it was showing me this sort of big circle here. And so there are limits to accuracy, particularly when you're indoors with poor GPS signal. Manhattan is actually a great place to test location services because there's this urban canyon effect goes on where GPS bounces off buildings or you don't have a clear view of the sky. And so you'll find that GPS signals will drift, or if you open Apple Maps or Google Maps, it'll have your blue dot, on the opposite side of the street. And these are just sort of, weird quirks that you contend with. We found in terms of, practical limits to accuracy and what's really reliable. For outdoor accuracy, 3 to 5 meters, clear sky. A lot of our customers are building use cases around curbside pickup or drive-through. So we always say, a few parking spaces, and that's assuming you get, strong GPS signal. Indoors, I would say building level accuracy is kind of the best way to think about it. Typically indoors, unless you're, standing close to the window, the location fixes are going to come from Wi-Fi scanning. And this is enough for a lot of geofencing use cases, but definitely limits to accuracy. Some limits to working with client-side geofencing. You can only register 20 CL regions at a time. You can do 100 on Android. What happens if you register more than 20? Not really clear from the docs. Is it first in, first out? Not sure. I think just in general, there are some weird quirks and kind of documentation gaps when it comes to location services, and you just kind of got to go out and test it. I think that brings me to my next point, which is just kind of challenges testing and debugging. One of our company values here at Radar is walk a mile. It's a sign on the wall there. Part of that comes from you want to be a successful, product engineer, mobile engineer at Radar. You got to get up from your desk. Got to walk around, go walk around the block, go walk to the park. This screenshot here actually came from a test that one of our engineers ran a couple days ago. You really can't test location features sitting at your desk and running simulator. You got to get up and run it on a real device. You might set up a geofence and walk over to it and not get an event. What happens? Good luck. Your phone, unless you're lugging around your laptop with your phone plugged in, probably not going to have logs. You're going to have to capture the logs. There's no dashboards to look at, and so oftentimes we talk about the challenges flying blind when it comes to working with location. If you've managed to get background location opt-in from a user, both iOS and Android are just going to incessantly remind them to turn it off, which obviously, it's a good thing for folks to be aware that they've granted location permissions. This makes building background features challenging. A lot of our customers have seen background location opt-in rates kind of flatline or decline over the years. Even if you've kind of gotten all of this working, sometimes location services will just freak out. This is particularly true on Android, but you'll occasionally have latitude or longitude value like zeroed out or something kind of out of range doesn't make sense. Just adding error handling for that. And then, I think to top it all off, like you can't really always trust location updates from a user. There's a ton of great content about this on Reddit. Folks spoofing their location. Play Pokemon Go. DraftKings and FanDuel have to contend with folks spoofing their location because mobile gambling is only legal in certain states. There are some new features both on iOS and Android to be able to detect if a location is spoofed. But if you jailbroken the device or rooted the device or compromised the app or whatever, you can always override it. So those are just sort of some of the things to watch out for. In terms of like real superpowers and kind of cool features that I think a lot of folks don't know about, we work a lot with the location updates background mode at Radar. So this is if you go into your project settings and go to background modes, toggle on location updates. This lets you basically run location services freely in background. This can be useful for navigation use cases, for example. So if you use the Google Maps app or the Apple Maps app and you start navigation, it used to be a sort of very conspicuous flashing blue bar at the top of the screen. It actually really bugs me. There's like two arrows that are kind of different. It's pointing up, and anyway, but that's kind of what it looks like today if you have the background location indicator on. But you have to go through some additional hurdles with App Store approval. But this is actually incredibly powerful. So one thing it lets you do is keep the app running forever. It can be really challenging to kind of keep the app running reliably, definitely in the background. Maybe you're building a delivery tracking app and you want to make sure the app is staying alive for the full duration of the delivery, or maybe you're building a workforce management app and you want to make sure that the app stays awake during some shift. Unless the user force kills the app, you can stay running indefinitely. You can do this both for use cases where that flashing blue arrow or bar is shown. But if the user's granted background permissions, you can also turn that off. And so you can actually keep the app running in the background without any visible user indication. Obviously, this is incredibly powerful, but be really thoughtful about battery drain and how much location data that you're collecting. But this is something that the Radar SDK employs in our what we call responsive tracking mode to basically overcome some of the limitations around geofence accuracy and number of geofences. We actually do a lot of our geofencing server side. We can request really accurate location updates in the background for really precise drive-through geofences or curbside pickup geofences or whatever. But this is one thing that's incredibly powerful. We talked a lot about requesting background permissions and background location reminders. It can make it challenging to both get background opt-in and then keep it. One of the most common use cases that our customers get excited about is location-based notifications. There's a really cool, kind of lesser-known notification feature or notification trigger called UN location notification trigger, where you can basically construct a circular region or a geofence. You can then attach it to a notification trigger and then schedule that notification. And the really cool thing about this is that it actually works even with foreground permissions only. So you can pop location-based reminders and notifications even with only when in use permissions. Again, kind of subject to the limits of client-side geofencing in terms of 20 geofence limit and limited accuracy, but pretty cool. And something that you can use to power location-based reminders even with only foreground permissions. CL Visit, I talked about the visit monitoring service earlier. When I was at Foursquare sunk a ton of R&D into developing this feature called Pilgrim, which basically was a sort of place visit detection feature. Apple then added visit monitoring later on, which is basically exactly what it sounds like. Stop detection, place visit detection. You can call start monitoring visits, and you'll get callbacks whenever a device arrives at a location or departs a location, which is pretty cool. If you want to understand when a device stops at a place versus walking or driving past it, this is a pretty powerful feature. And in theory, iOS gets smarter over time. You can actually see which locations it thinks that you've stopped at. If you go to settings, privacy, location services, significant locations, you can actually kind of browse the locations that iOS thinks that you're spending a lot of time at. It's pretty reliable. We found that there's some false positives. It can be slow to fire or quick to fire sometimes, but a pretty cool thing to have in your arsenal. And then, last but not least, this might be kind of obvious. I think a lot of folks think that Bluetooth is kind of this separate thing, separate permissions. But we've actually started to see a lot more customers interested in beacons at Radar. I feel like iBeacon got a ton of hype like 5 years ago, and it kind of died off. But it's actually quite intuitive to work with it in the context of the region monitoring service. Obviously, you can deploy, iBeacon proximity beacons. But one thing that I think is really cool that a lot of folks don't know about is there are actually a lot of iBeacon capable devices that might be lying around your office or your work site. Any iPad or iPhone can broadcast as beacons. So a lot of our customers have iPads deployed at a point of sale system. They can activate those as beacons. Even most modern wireless access points, we have Cisco Meraki routers around here. You can flip a switch in the admin console and they can broadcast as iBeacons as well. And the thing that's really cool is you can actually use this in tandem with this, because it's just another region type. So hyper accurate location-based notifications, even with only foreground permissions, maybe triggered off of some beacon-capable devices you already have installed at your locations anyway. So those are some kind of cool things that I think fewer folks know about that we're either have or are working on integrating into the Radar SDK, because we think they're really cool. And then I'm almost out of time, so I guess just some kind of predictions or thoughts on the future of core location. I talked a little bit about practical limits to accuracy, but one thing we always tell our customers is the blue dot gets a little more accurate on the map every year at Google I/O and WWDC. I think that's going to continue to be the case. There's a new generation of GPS satellites that are being deployed. GPS receivers get better and better on these devices over time. If anybody's played around with AirTags, I have a bunch of them. Ultra wideband is sort of the successor to iBeacon. I think is really exciting and really powerful. And so I think location services will sort of asymptotically approach near perfect accuracy and near perfect battery efficiency over time. We talked about some of the challenges requesting location permissions. I think we sort of reached a high watermark for how hard it is to request location permissions. I think Apple and Google have done a great job closing the gap that some bad actors were, quite frankly, exploiting in terms of how easy it was to request location permissions. So I think that will start to stabilize quite a bit. I think we're going to start to see more privacy-friendly background capabilities, where you as a developer can lean on the OS more. I mentioned that UN location notification trigger, but things like background trigger or location triggered push notification reminders. You can imagine a future version of iOS 25, where if I pull up my phone at the airport, it knows that I'm at the airport and it's showing me the airline app, the hotel app, the most relevant apps instead of just a static home screen. And I wouldn't be surprised to see Apple expose more OS level capabilities where you can say, hey, I want my app to show this message or show my app icon or something in these areas, and just sort of hand it off to the OS to handle that in a privacy friendly way. And then finally, just thinking about new platforms and devices, we're very focused on smartphone location use cases at Radar. Supposedly, Apple's going to release some, mixed reality AR, VR glasses later this year. Augmented reality, in our view, is all about overlaying location context over the physical world, and so it'll be cool to see the location capabilities there as well. So that's it. Hopefully, this was somewhat interesting, useful. We spent a lot of time thinking about this stuff at Radar. Our goal is really to abstract away all the challenges working with location services. We didn't talk about geocoding or POI data or any of that fun stuff. But our goal is to help you slay the bad guy, avoid reinventing the wheel, and make location simple. So that was helpful. We have time for a couple questions, or okay, cool, yeah.
So it's interesting. You said you do server side. And you didn't mention the Russia's wallets, which iOS means. They were talking about they don't block it because of Russian free war.
Yeah, it's interesting. We've actually done a bit of experimentation with Huawei support on Android, and there are actually some really cool indoor location capabilities there, like super accurate location capabilities. Oh, sorry. Yeah, please repeat the question. We can also pass this around in the future.
Sure. Repeat the question. Repeat it now. Can you hear? Okay. I asked, Nick said you guys do server-side rendering of, I don't know, what does that mean? Do you actually figure out the information, the GPS, on the server side or on the device? Number one. Number two, iOS, I haven't done Android in a while, but iOS uses GLONASS, which is the Russian satellite, blah, blah, blah. So they were talking about because of the Ukraine war, they might block it. So are you guys aware of that and how it's going to be? So that's the question.
Yeah, I think I mentioned that China has some GPS-esque satellites as well. I think honestly there's a state of the world where hopefully this doesn't happen, but somebody could tackle the GPS satellites and take them out, right? And so I think there's both platform risk, sort of working with iOS and Android location services, but also this is dependent on a lot of surrounding hardware. Like I don't know if I have any predictions on that matter specifically, but it's definitely interesting to think about. In terms of server-side geofencing, you can't really set up Polygon geofences on the device. You can implement your own version of Polygon geofencing, but we have customers who want to set up geofences for malls or for airports or a precise area of the parking lot. Whereas when you construct a CL circular region, it's a circle, right? It's a point and a radius. So we're able to do things like Polygon geofencing by capturing a lat long with the desired accuracy, sending it up to the server, generating the event server side, and then kind of routing that out to webhooks, and also back to the SDK. We do use client-side geofences as well to sort of wake up the app at appropriate times. So I think a mix can make sense.
If you're offline, this doesn't work.
Yeah, we actually just launched offline replay, so we can capture location updates offline. We can capture client-side geofence entries offline, and then play them back later. But yeah, definitely some limitations. Yeah.
I have a question about the iOS native region monitoring. You mentioned there's some mentioned limit of 20, and then there's another limit on top of that, and that's been consistent with my experience years ago. That what is actually the documentation on that? It's very vague. Is anyone considering the potential that would come from region monitoring on iOS? Is there anyone out there who has really tried to document how it actually behaves and what situations people have encountered empirically?
Yeah. So just to repeat the question was, there are things like the 20 geofence limit on iOS. Some of it is kind of poorly documented. Has anybody, attempted to document some of it? We've written some blog posts about it. We've written a little bit about kind of the differences between iOS behaviors and Android behaviors. Part of our approach is just how do we abstract it away? Like, why should you even have to worry about this if you're Panera Bread is a radar customer, for example. You have 3,000 locations. You could sort of do what Apple describes here and swap out the list based on the user's location, or ideally you could just import 3,000 geofences and write one or two lines of code and just kind of have it work. So we've put a lot of our energies there, but there are other limits as well. I think we talked about iOS supports circular geofences. We found that if you set a radius down to 20 or 30 meters, it'll just fire an entry, 100 meters out. So there are kind of limits to accuracy as well. Just a fair number of quirks.
A question I'll pass it to you after. Regarding iBeacons, I used the SDK way back when it came out, and it was quite unreliable. I'm wondering how it has evolved over the years. If you think it has a future, and if there's better technologies for tracking indoor location.
Yeah. Do you remember which SDK you used?
I used this Note, and I don't know exactly. I think it was actually that exactly.
Yeah. We've been following Estimate for a long time. super cool company. They were super popular, I feel like 5 or 6 years ago. Yeah, I think the way these iBeacons work is they're, little hardware devices that chirp out some identifiers at every couple hundred milliseconds, and that can work in some cases, but these Bluetooth signals don't travel super well through concrete. They bounce off the wall. They can go in and out of range. So one thing you might observe if you're working with CL circular region is that even if the device is stationary, Apple might jump you in and out of the geofence. We've observed the same thing happen here. So you'll sort of repeatedly enter and exit beacon range, even if the phone is right next to the beacon. So kind of like we do with location services for our beacon capabilities, we try to do some throttling. You have to be sufficiently far away to exit, or you can only enter and exit so many times in a given period. Part of it's just sort of the nature of the beast, and it's the actual OS that's doing that. Probably not us about. In terms of the future, I kind of feel like iBeacon might be primed for a comeback. Again, I think a lot of people kind of don't realize they have these beacon capable devices. The most common objection that we hear is not that. It's, oh, man, I don't want to buy 10,000 beacons and roll them out in the field, and then the batteries are going to run off for a couple of years and I have to replace them. So we're finding a lot of folks are, just activating iPads or, Wi-Fi access points as beacons. Again, I think, keep an eye on ultra widebands. It's, I think, more battery efficient, more reliable. It also gives you things like direction and distance, even with only a single, ultra wideband transmitter. And I think Estimote actually just released their ultra wideband, like beta devices. So I think that'll be interesting to follow as well. Yeah.
And my question was actually related. I just wanted to know what you thought the future of indoor mapping was.
Yeah, it's a great question. There are some really cool startups in the space. There's one that was called Dent Reality that just rebranded as Hyper. There's a company called Orient with 2 eyes. And so I think there's kind of indoor location use cases, which I would say Radar does support today. We have a lot of retail customers with big store footprints that want to understand not just if you're in store, but also, are you in the shoe department? Are you in the golf department? Are you near the registers? And I think the way folks are using Radar to solve that today is they have a Wi-Fi access point in this department and this department, and they can activate all of those in Radar. I think like true indoor wayfinding, where you're in a grocery store and you're trying to find the carrots, and you open the app and it shows you a map of the store, is what some of the startups that I mentioned do. I think that's really cool. It's really hard to build and maintain those store maps. If you're a retailer and you say the t-shirts are over here and then you move it, you got to go update the maps. And how do you even manage and draw these maps? So there's a definite interest in it, I think, particularly for like large footprint venues, airports, stadiums, department stores, malls. But in the same way that there are challenges rolling out beacon hardware, there's, I think, challenges maintaining those as well.
So you spend a little bit of time talking about the permission system and how it's becoming a little bit more closed. How do you think that, and this applies as much to Android as iOS, but how do you think that sort of the EU regulations around sideloading are going to affect this, in the sense that, are you sort of planning to open, the gates, the floodgates, the moment that sideloading becomes an option? Or is that like something where you need to strike a balance between usability, where people can still download stuff from the App Store, versus these apps that can be downloaded from anywhere but can get location permissions perpetually?
It's a great question. So I'm honestly not totally sure how side loading and kind of alternative app stores will work with permissions. My hunch is it's going to be subject to, those apps are going to be subject to the same location permissions as any other app, because they're kind of OS level. I think in general, what Apple and Google have been trying to prevent is apps collecting location data just for the sake of collecting location data, selling it to hedge funds or selling it to ad tech companies. You want to sort of avoid the situation where, my grandma downloads a flashlight app and it's like collecting all of her location 24/7 and selling it to a hedge fund. So I kind of feel like it's mostly mission accomplished there, at least from an OS perspective. It's very hard to request background location permissions now. It's very hard to keep them, and I think as an end user, like it's pretty hard to accidentally opt into them. I think I wouldn't be surprised to see continued, development and maturity of government privacy regulations, kind of along the same lines. In general, our view at Radar is like follow the rules. Like you should honestly be out in front of the rules because they might change or the goalposts might get moved even further, and really like build valuable features for end users and be very clear about what location data you're collecting. Don't try to like skirt the rules with how you request location permissions or side loading or something like that. Hopefully that answers the question.
And the last question from the chat, and then we can take a little break.
How and why does turning off the location indicator keep the app alive forever?
So basically, if you have the location updates background mode, and you make sure the location manager doesn't pause or otherwise shut down, basically iOS will allow the location manager to continue to run indefinitely. You can sort of choose, assuming the user has granted background location permissions, you can sort of choose whether you want to show this indicator or not. So really, it's the act of keeping the location manager. If you have this location background mode,
It's my fault.
good. I was just saying, if you have the location background mode, and you say allows background location updates equals true, and location is running, iOS is going to say, cool. We're going to keep giving it to you. So please use responsibly. Yep. Cool. Well, it was fun. Thanks, everyone.
There we go. Well, hi and welcome. My name is Carlo. I'm an engineer at OneTouch, and I work primarily with iOS. Today, I'm going to talk about my experience using Kotlin Multiplatform, and especially from an iOS perspective. So I'll start with some background about OneTouch and the product I've been working on. Then I'll talk about sharing code between platforms. I'll introduce Kotlin Multiplatform, and then move on to Kotlin Native and how you can use it on iOS. And finally, I'll share some learnings. So some of you might not know OneTouch. We are a digital design agency. We have 5 studios across 3 countries, one right here in New York City. And we work with established brands to create great experiences for their end users. And we primarily build native mobile apps, but not exclusively. And we work with many different products and services, including some major brands in Sweden. But for the past 4 years, I've been part of the team building the Post-it app, the official app for the Post-it brand. And with the Post-it app, you can capture physical notes and essentially turn them into digital objects. Then you can rearrange them into boards, you can edit them, and so on. And you can also create notes from scratch, adding digital text or drawing. And the apps are native. They run on iOS, Android, Chromebook, and so on. Now, as a next step, we wanted to allow users to collaborate in real time and across devices. So we started designing and building a whole new experience, including a web client. And last year, we've actually launched this as a Microsoft Teams app in collaboration with Microsoft. And here it is in action. But so because this product is all about collaboration, we needed a robust way to sync changes between devices. And you might have seen software that looks a bit like this. Users are asked to manually pick a version whenever there is a conflict. And obviously, this wouldn't work in our case. So we needed a way to automatically resolve conflicts. So the approach we chose to solve this was a model based on conflict-free replicated data types. And this is a fancy term. I won't go into the details, but if you're interested, I've actually held another talk about this last year with my colleague Anders at DroidCon London. You can find it on the web. So because the model is shared across all platforms within what we call a core library, it includes all of the logic to resolve conflicts automatically. And so to recap, we needed a model that would allow users to collaborate from 3 very different platforms, iOS, Android, and Microsoft Teams, so web, and have the same syncing logic in the backend as well. So essentially, 4 platforms to work with. And because of how CRDTs work, it was actually crucial that the conflict resolution logic was identical in every platform. So in other words, sharing code was not just desirable, but actually something we needed. So we started looking into possible solutions. And you probably know that the cross-platform universe is actually quite rich nowadays. There are UI frameworks and low-level technologies. So if you want to share as much code as possible between platforms, you might pick a UI framework. And there are many, but the core idea is the same. You want to write code only once, and you want to run it across all different platforms. Otherwise, you can choose a low-level technology and maybe create a library, share business logic. So you can share as much or as little as you want. And of course, this is a spectrum. We wanted to keep the shared code as focused as possible. So without forcing design decisions that might not fit well with all of the platforms. So we chose to go with a library that would just take care of the low-level logic. Why did we choose Kotlin? And why do I think we should do the same? Well, it's open source. They have a clear timeline for new features and a large community. It works great on Android, unlike alternatives. And in fact, your fellow Android developers already use it. It's modern. It has a lot of powerful features. And it's actually not too different from Swift. And let's take a quick look. So they're both object-oriented, and they have functional programming features. They both inherit from old languages. They have built-in null safety features. They support structure concurrency. And their syntax is actually quite similar. So here's a super simple example where the syntax is actually identical. And here is another that shows the null safety features, almost identical. And one more when we define and call a function. Pretty close. And I mean, of course, these are a bit cherry-picked, but the point is it's not difficult for a Swift developer to learn Kotlin. But perhaps the most important feature of Kotlin that we care about is it runs on a lot of different platforms. So it can be used on Android, web, it can be compiled to WebAssembly, and for native targets like iOS and Linux. And in fact, it's a little bit overwhelming when you first take a look. And let's be honest, these names are not helping them. So within the same multi-platform project, you can have both shared code and platform-specific code. In fact, you can even use platform-specific APIs if you want. You can import things like UIKit on iOS. or use the DOM for on the web. But obviously, as iOS developers, we are interested in this part, Kotlin native, which allows us to compile Kotlin for targets like macOS, iOS, watchOS, and so on. So let's take a look at how we can work with it. So let's say you want to develop a multi-platform library, just like we did for the poster project. The first thing you might be wondering about is how do you get it into your iOS app? And you should know that when you compile your Kotlin library for Apple platforms, you're going to get most likely an XC framework. And if you're not familiar with this, it's just a fancy folder with binaries for each target. So you're going to have one for iOS, one for the simulator, one for macOS, and so on. And this can be integrated in your project in a number of ways. So the first way is to compile it on the fly through a build phase in Xcode. And it might work well if you have a monorepo, you have the same project, you have one repo for iOS and Android, for instance. But you have to link things manually. You're going to get longer build times, of course. And you also have to force all of your developers to have the Kotlin toolchain installed, which is maybe not ideal. Another way is obviously to just drag this XC framework into your project and check in this binary into your repository. But if the library is in active development, this is not great, because obviously it's going to take up a lot of space. You might even have to use Git LFS and so on. So the best way is probably to have a separate repository for your library artifacts and use it as a remote SPM package, which is actually what we ended up doing in the poster project. So how does the code look like? Let's say we want to implement a fruit class in our shared code. Sorry if this is extra simplified. And we also define an Apple subclass, because why not? And in Swift, this looks pretty much as you would expect, with familiar foundation types. And of course, there is some weirdness with that integer 32. And that's just because by default, Kotlin uses 32 bits integers, but it's nothing too crazy. But let's say now we want our fruit class to have a color property. How do we do this? Because colors are typically platform-specific types. Well, here's when expect and actual come into play. And these are keywords that you can use to define types and methods. You can use these in your common code. And then you have to implement these for the different platforms. So in this case, we would have a specific implementation for iOS. And remember that we can just import platform, we can use platform APIs here. So we import UIKit and we just define color as an alias for UI color. And of course, you can do the same, something similar for other platforms. Super easy. And then you can just use color in your shared code. And once you compile this, if you look at the generated Swift interface, that color is going to be a UI color. So it's something that your iOS developers will be familiar with. Very nice. And this is how it looks like when you would use it. So you don't need to do any weird color conversions on the iOS side. Because ultimately, it's important that this library is nice to use for iOS developers as well. And this is where there's still a little bit of work to be done. So to start with, pure Swift modules are not supported today. And this means that everything goes through Objective-C. And that has a number of consequences. Yes, you don't get to use Swift value types. And that means you lose features like copy and write and so on. And almost everything becomes an object. You also don't get free functions. Everything is scoped. And since Objective-C doesn't have real generics, you can't take advantage of the power of Swift generics. In fact, this is the real interface that you get when you get your XC framework. It's an Objective-C interface. And they are working on direct interrupt with Swift. But if you ask me, I think this is going to take a long time. So I wouldn't hope for it. And another thing that isn't great for iOS developers is companion objects. And this is a common pattern in Kotlin, and it's kind of the equivalent of static properties and methods in Swift. Not quite, but you get the idea. And in this case, we have this class, and in Kotlin, we can just access these properties like fractional index.min. We just use the type as a scope. In Swift, these must be accessed through this companion property, which is very annoying because it makes things very verbose. You cannot use, the type inference, things like that. So it kind of sucks. And this is how the generated interface looks like. But it's not all bad. There are actually some things you can do to make your interfaces nicer to work with on iOS. So let's say, for instance, we have this Kotlin fruit class, and it has a method. And obviously, we don't want to use this weird type directly in Swift because it has Kotlin in it. So we can actually rename it and do the same with a method. So it's going to look more familiar with to our iOS developers. They're going to be happier using it. And there's a lot more that I'm not mentioning because we don't have the time, but you get the idea. So another thing you're probably wondering about is how are you going to debug this if it's Kotlin code? And you probably use Xcode as iOS developers. So how are you going to find issues in the Kotlin code? Well, there's actually this great tool made by TouchLab, and it's basically a plugin for Xcode and LLDB. And it allows you to keep working with Xcode, the same ID you're used to. And you can actually drag in your Kotlin source into Xcode. And this looks a bit alien, but that way you can actually set breakpoints directly in the Kotlin code. And it's pretty cool. You even get to see the variables in the scope. In this case, I'm setting a breakpoint in the code that is supposed to convert a hexadecimal string into a UI color. And if we go down the stack, we see that this is actually called in the constructor for our Apple class, and then ultimately it's used in our Swift UI app that uses this type defined in the Kotlin library. So pretty cool. And of course, it's not always smooth. LLDB sometimes just doesn't know what to do with the types that you get from Kotlin. And you're going to see these dots over there. But it's good to know that there are ways around that when you really need it. And crash reporting is also something we have struggled with. Because whenever the app would crash in the Kotlin code, our stack traces would look something like this, which of course is not exactly useful. So what we ended up doing was writing a special handler for all uncaught exceptions from Kotlin, and then basically collect a breadcrumb with our regular crash reporting tool, so that at least whenever we would get the crash, we would still be able to read this breadcrumb, and we would get the human readable message basically attached to the crash log. And I believe this is already something that they have improved, and hopefully something that will continue to improve in the future. So also documentation. Working with Kotlin Multiplatform, you might end up in a situation where it's your Android colleagues that write most of the shared code because they already know Kotlin. So But this means that it's even more important to keep documentation on the shared code. So obviously, you can do this directly in the Kotlin code, and then maybe you generate, HTML documentation automatically that everyone can consult. But what's even nicer is that you can export this documentation directly in the generated interface. So your iOS developers yourself will be able to see the documentation directly from Xcode and from the quick help bubble. So I want to leave you with some general learnings that we have acquired along the way using Kotlin Multiplatform. And the first is that you should start with the code you want to share, and then take it from there. And that's why the library that we built using Kotlin Multiplatform for Post-it is called Core Library. It's easy to get excited, and then you might want to add a lot of things in the shared code. But once you start having to reinvent the wheel for each platform, you kind of defeat the purpose of using a multi-platform technology. And of course, Kotlin Multiplatform works really well for Android, which already runs Kotlin. But as you saw, it doesn't always translate to Swift very well. And the same goes for other languages. So it's important to be aware of that while you're designing your shared API. And you have to frequently validate and test consuming the code from other languages. It's not enough to just write tests directly in Kotlin. You actually have to make sure that your API is nice to use in other platforms, and maybe even have like platform-specific unit tests. So, and as I mentioned earlier, we realized how important documentation and knowledge sharing can be. So most iOS developers and web developers are not familiar with Kotlin and the toolchain. So we actually saw this as a great opportunity to learn and collaborate more with Android developers. And of course, we use code review to spread the knowledge about this multi-platform library. And we also made sure to keep detailed documentation that was easy to access. But perhaps the biggest learning was Kotlin Multiplatform itself, because when we first started exploring this framework, I was very skeptical as an iOS developer. I didn't want this alien language in my code base, but it turned out to be a great choice for our product, and it had zero impact on, zero compromises for the users, and very little overhead for us developers. So I think if you have the right use case, I highly encourage you to give it a try. And that's all I had. Thank you for listening. And if you like this talk, you can join our Dev Lounge Meetup group. And you can see it here as well. And yeah, that's it. Thank you for listening. Yes.
Thank you.
Yeah, thanks. So on one of your earlier slides, you showed UI color and some Kotlin color. Is there some kind of like library or something that exists for common types so that people don't have to create all of these?
I mean, typically you can just, you can import, UI kit, and you already have access to UI color and so on. But if you want to do, in this case, we want to be able to initialize color from a string. That's not something that is available in UI kit, so you have to implement that yourself. But this, if you mean
just like the type aliasing, like do you have to? Is there something that exists so you don't have to go through and type alias?
I believe there are some third-party libraries that do this, but ultimately, in our case, we had to do this so few times that it was not worth it. Adding a dependency just for that. Yep. Sorry.
It's kind of sad that it still has to translate to Objective-C. That's kind of
Yeah.
depressing.
Sure.
You're gonna have to run into memory issues because Kotlin, if I remember correctly, is garbage collection. It's GCA. Swift is Arc. So unless you work with structs all the time, like how do you handle? So what happens with what happens with memory management? How do you handle that?
Yeah.
You have to choose things that are. By the way, yeah, that's my question. How do you handle
Yeah.
memory management?
So performance is a very big topic, and unfortunately, I did not have time to cover it here. But it's something that we have definitely investigated, and we basically saw very little impact, even though the product that we were building, was quite performance critical or performance heavy. So they do have their own garbage collector, and recently, actually, they've released a new memory model. They claim is even more efficient than Arc. Now, I don't know if that's true. We haven't put that to the test, but yeah, it's supposed to be pretty good at managing memory. So we have noticed no performance issues. But you do see like objects, remaining alive for longer, which we're not used to that as iOS developers because Arc is pretty aggressive. But ultimately, what we care about is the impact that it has on the users, and we didn't see any. So.
First up, thank you for the Post-it note app. I use it all the time, and
really?
anytime I show someone it, it blows their mind. You should all use it. It's amazing. So I have a side project that I decided to use Kotlin Multiplatform for, not because I had a good use case, just because I was like, this seems fun,
cool.
and it was a choice between not having an Android app or having one. So thought I'd give it a go. But I started it off a sample project a year and a half ago, and then I've been kind of terrified to update the version of Kotlin Multiplatform that I'm building on because it's early life, and I assume a bunch of stuff is going to break when I do so. What is that update story like? Is there anything that will help me through that?
Yeah, so you kind of have to be ready for that. When we started using Kotlin Multiplatform, it was still bleeding edge, not even beta, but it was too cool not to try it. And we've been working with it for a couple of years now, and of course, since it is quite early still, there's been a lot of breaking changes every once in a while. But nowadays, I think it's stabilizing now. So you should be fine. But yeah, breaking changes are definitely part of the process when you're using still technologies that are being worked on. And I believe Kotlin native specifically for iOS and the part that is iOS and Android, so what is called Kotlin Multiplatform Mobile, has just been promoted to stable. So.
Yeah, Carlo, you mentioned that there is some issues with the disambiguation. With disambiguation of stack traces.
Yes. Yeah.
Usually, when something is distributed as a compiled framework, there is disambiguation file with it.
Yes.
Doesn't Kotlin Multiplatform generate something like that?
So you can actually choose to build your Kotlin library either as a dynamic library, and then you do get symbols separately. But you can also choose it to build it as a static library, and then you don't get symbols because they become part of the app's symbols.
And I guess you picked the static one.
We picked the static one in the end, just because it was nicer to work with. But yeah, the symbolication is something that they are improving. So I believe that it's already better than what I'm showing you here.
Thank you.
But still.
Questions in the chats?
No.
Questions here?
I had a question in the chat. Does anybody?
Yeah, you can hear you.
They can hear me. I mean, so given a large code base in Swift and Objective-C, Is this a reasonable way to try to build an Android app that shares most of that code?
Sorry, I didn't quite get that.
So given a large code base in Swift and Objective-C running in iOS, is this a reasonable way to spin up an Android app that uses most of that code without changing it?
No, I wouldn't say so. I mean, this is great for like isolated features or libraries. You know, if you already have an existing code base that you want to all of a sudden share, this is not going to help that much.
Sorry, the lights went off. We're almost back.
Why won't it help? Maybe I'm not understanding why it doesn't help.
It could be that you have a lot of code on Android, and then you can try to port some of that through Kotlin Multiplatform and use that on iOS. That's definitely possible, but it's not going to be, you know, a checkbox. But it's definitely possible, and it's something we've actually done as part of another project.
But the other way is much more difficult?
Absolutely, yeah. I mean,
why is that? I thought it was interoperable.
It is interoperable, but let's just say that it's not optimized for that use case. Yeah.
Okay.
So you still have to have most of it, like your shared code has to be in Kotlin.
Oh.
So if you're starting from Swift, yeah.
Yuck. Oh, that's terrible. Okay. Sorry.
So you could actually, yeah. Yeah.
One more question.
Sure. Can you tell us a little bit about what you ended up sharing, like the kinds of things you ended up sharing, and maybe what percentage of your code base that represents?
Yeah. So if we go back a little bit here. So what we ended up sharing was all of the logic that was needed to basically handle conflicts from different updates coming from different clients. And this was in the context of this product. So we have a lot of updates coming from a lot of different clients. You know, the logic for syncing all of these changes needs to be the same in a lot of different platforms. So what we ended up putting in this core library, as we call it, this shared library, was all of the models. So in this case, you're going to have models for the nodes, you're going to have models for the groups, and all of that part is shared Kotlin code. And then whenever there's a change, we use WebSockets in this case, and what the apps do and what the clients do is they receive this WebSocket message, and then they pass it to this core library, and the core library handles everything. It knows that there's been changes, it knows what the current state is, it knows what updates to make to the model, and then it says, you know, here is the new updated model, here's the latest state, basically. Yeah. Percentage-wise, you know, we started from an existing apps that had already a lot of legacy code. So just this model and just the syncing, I would say that represents maybe 5 to 10% of the code base. Yeah.
All right. Thank you.